Okay, this is paper 1 from the 2026 chemistry exam, Nat5, and I've got a document here I think you should read. I'm just going to pass through it, but this is a quick disclaimer. It took me a couple of hours to do the exam. I do it as almost as in exam conditions. I'm not sure I'm 100% correct in everything, so don't. None of this is guaranteeing anything. I'm not a marker, so I can't give you decisions and things. If you spot anything that I've got wrong, let me know. I'll update the errata in the description. So check the description if you think I've got something wrong in case somebody else has already spotted it and I've already updated. This is about learning while the exam is fresh in your mind. It's a learning experience, and that's why I do these. You'll notice that I'm not going to do higher, I don't think, because much higher stakes exams, and I think it's important that I do those really correctly, which means I have to spend a lot more time on them. This is a learning experience. Okay, let's get on with the paper. Okay, question 1. Let's get started. Question 1. Which of the following statements is not true when a catalyst is added to a chemical reaction? Well, there's a bunch of different options here, and I thought that was quite a hard question to start with, but the time taken for the reaction to finish increasing would not be a catalyst. That would be something that extends the reaction rate. So B is the one that's correct there. A massive product formed is the same. Catalyst has no effect on that. Catalyst can be recovered unchanged. The rate of reaction increases, the rate increases. That's true. Which of the following compounds has molecules that have the same shape as those found in ammonia? NH3. Okay, so what we have to do is we have to find a compound, one of these compounds here, that has 4 atoms in it, because there's 4 atoms in NH3. and we also have to find molecules. So we saw this question last year, actually, as well. I think it was last year, was it, where they asked about this? And so we know that sulfur dioxide is not a molecule. Sulfur dioxide is a molecule, I beg your pardon. Sulfur dioxide is a molecule. Carbon dioxide is a molecule, but that's got 3 atoms. This has got 3 atoms. Hydrogen fluoride is a molecule, and it has 2 atoms. Phosphorus fluoride has 4 atoms, because phosphorus has a valency of 3 and fluoride has a valency of 1. So that's going to be PF3 is going to be the same, NH3, so phosphorus fluoride is your correct answer. Okay, a graph showing the volume of hydrogen gas produced over time when 2 grams of zinc lumps is added to 100 centimetre cubed of 1 molar hydrochloric acid. Right, this is, there's a couple of little wrinkles in this exam. 1 gram of zinc powder, so we've got less zinc and we've powder instead of lumps, so the reaction is going to go faster, but it's going to produce half the amount of product, and the correct answer for that is going to be C. It's actually really quite difficult to get this lined up. So that's the same rate as that and that, but these 2 rates are faster. We're presuming that the scale is the same in each place. So that would be unfair if they didn't do that. So correct answer was this one. So the rate is the same as this. The rate is faster than this one. Faster, that's steeper, right? So that's... We'll drag that down. So that's this one here is definitely a faster rate, and it produces half the amount. So there you go. Greatest number of electrons is found in 1 mole of which of the following gases? Now again, we need to watch out for this. A mole of the gas is going to be the molecule, if there is a molecule. So that's going to be the important thing. So neon forms monoatomic gas. Fluorine is a diatomic gas. Oxygen is a diatomic gas. Nitrogen is a diatomic gas. Okay, so how many of them have the electrons? Well, the electrons is going to be the same as the atomic number multiplied by 2. Okay, they don't lose or gain any electrons here. They're just sharing them. So neon has only 1 atom, so it's going to be 1 by the number by mole. So it's 1 times mole times 10 electrons for its atomic number. That gives you 10 times the moles. Fluorine has 2 times 9, which gives you 18. Oxygen has 2 times 8, which gives you 16. Nitrogen has 2 times 7, which gives you 14. So the correct answer is fluorine. You might have the trick here is the trap here is you just pick neon as the highest atomic mass with the most electrons in it, but you forget that these are molecules. So it has to be fluorine. All right. Table shows some information about an ion. There it is, electron 18, neutron 19, proton 20. The charge in this ion is, well, it has 2 more protons than it has electrons, so that's 2 extra positive charge particles in the structure, so it's going to have a 2+ charge. The difference in size between a sodium atom, and a sodium ion is due to the mass number decreasing, the atomic number increasing. Well, the mass number doesn't decrease because it's just lost an electron. The atomic number doesn't increase because it hasn't changed its proton number. The charge of the nucleus, so you can eliminate quite a few here because that's definitely wrong. That's definitely wrong. Charge in the nucleus is increasing. That's not true either because it doesn't gain any protons. Therefore, the number of occupied energy levels is decreasing. So if you weren't sure about this, go backwards and work it out, and D is your correct answer. All right, so question 7. Which line in the table shows the properties of a covalent network? And it's the big one. We haven't been asked about this very often, but it's this one up here. It doesn't conduct electricity as a solid or a liquid, and it is the highest boiling point and the highest melting point of anything, right? So it has to be A. Okay, try melting some diamond, you'll find out all about it. An electrolyte can be made by dissolving potassium chloride in water. Which line in the table correctly shows the solvent, solute and solution for this process? It took me a while to figure this out, but the solution, what they're meaning by solution here is electrolyte. So the electrolyte is the solution, and then the potassium chloride is the solute, and the water is the solvent. So the correct answer was D. Okay, lithium aluminium hydride has a gram formula mass of 38 grams. The percentage by mass of metal in the lithium aluminium hydride is equal to... Okay, the trick here was you had to remember that lithium and aluminium are both metals. You add those two together. There's only one of each of them. You add those two together for your numerator on the fraction, and you're going to get to 34. 7 plus 27 is 34, so the answer is C. Okay, an acidic solution. So it's acidic. and non-metal oxides give you acidic solutions. We've only got one non-metal oxide, so the answer is A. There you go. The name of this compound, what's this stuff here? So let's have a go at it. We'll just do it from here. So we have 1, 2, 3, 4, 5. So that's pentene. So and our ene counting takes precedence. So it's the smallest number for the ene value. So it's going to be pent 1, 2 ene. And then the methyl group is going to be on carbon 4. So it's going to be 4-methyl pent 2-ene. So 4-methyl pent 2-ene is B. There it is. Which of the following is another way of representing this structure? Well, this is just a process of elimination. Okay, so what you do is you start off with CH3, they're all there. And then you go CH and then CH3 in brackets. And then you can eliminate A and you can eliminate C. We're still carrying on with this. Then we get CHOH in brackets. CHOH in brackets is there for both of those. Then we get to this one, which has to be CH, and this one fell out because that's CH2, so B is wrong, and D has to be the correct answer. CH, CHC, and CH33. Okay, so which line in the table correctly describes the changes going from cyclopropane to cyclobutane? Cyclopropane is a 3-carbon cyclic alkane, and cyclobutane is a 4-carbon cyclic alkane. So the formula mass has to increase because there's more carbons, right? And the strength of the molecular forces, intermolecular forces, increases because the structures are bigger, and bigger structures interact more. There's not much else going on there. Intermolecular forces are still very weak in these things, so I'm not sure if cyclopropane is a gas. It probably is a gas, but anyway. So which of the following is the structure of vinegar? There's actually a question in the second paper on this where they tell you ethanoic acid, and they give you its formula in case you've forgotten. And if you remember that ethanoic acid was vinegar, you might have been able to go back and correct this. But this is it. CH3COOH is ethanoic acid, which is vinegar. Metallic bonding is the electrostatic force of attraction between oppositely charged ions? Nope, because that would be ionic bonding. 2 nuclei and a shared pair of electrons? No. because shared pairs covalent bonding. Negative ions and delocalized electrons, that's just wrong because electrons wouldn't be attracted to negative ions, they'd be repulsed. So it's positive ions and delocalized electrons. You'll have just learned that. That's a nice one. That's just basic knowledge. Which of the following substances will react with an acid to produce a gas? And there's a bunch of oxides here and a chloride. Magnesium chloride probably won't react with an acid at all, I'm not sure. Don't know. But anyway, metal plus acid reacts to form metal oxide plus hydrogen gas. So magnesium will react with an acid to produce a gas. Which of the following metals can be extracted from its ore by heating with carbon? Good grammar there, by the way. No apostrophe in the it's. And sodium, calcium, magnesium. These are group 1, group 2 metals, and I think they're going to require electrolysis to get them out. Iron is the one that you can extract from its ore by heating with carbon. Famously, the Iron Age, once they discovered that was the Iron Age. Which of the following metals would become liquid if placed in a beaker of boiling water? You may wish to use the data book to help you. Look up the melting points of all of these things and you'll find gallium is 30 degrees Celsius. In fact, you can hold it in the palm of your hand and it will melt because you need a good warm hand. Okay, which line in the table is correct for both the Haber and the Ostwald process? So you've got your catalyst and your product. Catalyst and product, make sure you get them the right way around. Ostwald process is nitric acid. Haber process is ammonia. Iron and ammonia, platinum and nitric acid is your correct answer. Okay, which of the following is true for elements nitrogen, phosphorus and potassium? You may wish to use the data book to help you. They are all non-metals. No. They are all found in group 5 of the periodic table. No. They are all elements essential for healthy plant growth. Yes. They have symbols in the periodic table that are the first letter of their name. No. All hence elements essential for healthy plant growth. If you've learned about your fertilizers, your teacher should have told you about NPK. Those are the 3 letters that you want on your fertilizer bags if it's going to be any use. Anyway, the diagram shows the path of 3 types of radiation as they pass through an electric field. Which line in the table correctly identifies the type of radiation that follows path 1, 2 and 3? Let's have a look at the paths. Path 1 is attracted to the negative plate, so it must be positive. So that's going to be an alpha particle, which is a helium nucleus, right? Number 2 goes straight on, so that has to be gamma radiation because nothing affects gamma radiation. It's got no charge. And number 3 is attracted to the positive plate, which must mean it's an electron, oppositely charged to the positive plate. So that's a beta particle. So we've got alpha, gamma, beta is the order we're looking for. Alpha, gamma, beta. I got it right. Well done me. Paper. Paper factories. You can use radioactive sources to measure the thickness of paper they produce. Radiation has to pass through the paper to a detector on the other side. Which line in the table describes the most suitable radioactive source for this use? I'm not sure about this one, but I'm presuming, just from safety point of view, a short half-life is the correct answer. Okay, we can eliminate alpha particles because they can't get through the paper. A sheet of paper can block alpha particles, so we eliminate those, and then we have a choice between long and short half-life. Now, I wouldn't go to the foot of our stairs if it turned out to be long in this, so it could be beta and long, but I'm going for beta and short because I think short is just safer, right, in machinery, which, so, I don't know, a short half-life would be better, maybe, but then if you have a long half-life, your source of radiation is going to last longer and you won't have to change it so often. I'm not quite sure. That seems to me to be something of a judgment call. So I'm not sure what they're going to put there. I would just say short because it would be safer. The materials won't hang around any longer if you have to throw them away and things like that. They wear out and you can replace them. I would go short half-life, but it's a question mark. Time taken for half of the nuclei of a particular isotope to decay. So it's saying half the nuclei of that isotope. And it sounds kind of nearly right. Right? So what's wrong with this one? Let's have a look at the next one. Half the time. It's not half the time. It's not half the time of anything. So it's the time taken. So not half the time for nucleus in particular. Okay, so time taken for half the mass of a particular isotope to decay. I think it's going to have to be the nucleus. The nucleus decays, not the mass. The mass doesn't decay, right? The nucleus decays. So I'm going to change my answer. I'm going to go for A. I think the mass doesn't decay, the mass decreases if a particular type of irradiation goes, because the mass won't change if we have, say, gamma radiation. Mass won't change, will it? Because it's just a rearrangement. So it has to be A. right? So that has to be wrong, that has to be wrong, that has to be wrong. Okay, I'm going to go for A in that one. Here we go, measuring cylinder and a tube. Which line in the table shows a gas that could be collected and measured using the apparatus shown? Well, the apparatus shown is a measuring cylinder, right, with a scale on it. And that's the important bit, I think, for this question, that scale, right? Because we have to collect and measure, that's the important thing, right? Using that apparatus, okay? So you might say that any gas that is denser than air, which is A and B in this case, denser than air, can be collected by this method, and that's true. But we couldn't measure the colourless gas because we couldn't see it, so we wouldn't be able to measure it because we can't see it. Therefore, we have to collect the brown gas, and we'll see the top of the brown gas as it floats up, and we should be able to measure the edge of the brown gas when it meets the air above. And so I'm going for A on that one. Tricky question, that, I think. Had to do a bit of thinking there, maybe. Transition metals can form large ions known as complexes. Now, this was all completely... this is a tricky one. A lot of reading to do, right? The name used for the metal in the complex changes depending on the overall charge of the complex. The table shows how the names change for the metals copper and iron in complexes with overall positive or negative charges, right? So metal in the complex, copper or iron. Let's look at the copper one. So if the metal in the complex is copper, if the overall charge of the complex is positive, you call it copper. The ion is called copper. And if the overall charge is negative, you call it cuprate. And here we have iron, and iron gets its own name if it's positive, and it gets the ferrate, ATE ending, if it is negative. Not only that, we use the Latin term for both of these metals, which is kind of interesting. Right? I'm not quite sure what they do with metals that don't have Latin names, but somebody can tell me in the comments if they want to. All right, so formula for complexes X and Y are given. Here's complex X, and all we really have to do here is look at the charge, right? If the overall complex is negative, it's going to be cuprate, right? That's copper. And the metal is copper, and it's negative, so it's cuprate, right? And this is the overall charge is positive. It says overall charge is positive. That has to be iron, is going to be the name of the ion here, and cuprate is going to be the name of the ion there, right? These complexes. So these are all a bit tricky, but anyway, I've gone for D. Cuprate for X and iron for Y. There you go. That's the end of the paper. Didn't need a calculator for that one. I think that's the first time in a while I've looked at a paper one for chemistry I didn't need a calculator for, but there wasn't a lot of sums in that. And you know what that means, don't you? It means there's going to be a stack load in section 2, which we're going to come to in the next video. Click a link. It's going to be around there somewhere. Okay? Hope you enjoyed that. Again, remember, this is National 5 is not high-stakes exams. I mean, it's nice to do well, of course, but you're in the learning process. You're learning how to do exams. It's your first time through National 5s, probably. First time through formal exams. And this is a learning process. It's good to get feedback on your paper at the end of that process within, otherwise you have to wait 3 months, right? Okay, so I hope you did well on that, and I'll see you in the next video.